Hi, I'm Alex Pault, editor of Evaluation Engineering, and I'd like to welcome you to another one of our Tech Exchange talks. Today's Tech Exchange talk was actually an interview we conducted a couple of months ago with Dan Kinzer. He's the Navitas co-founder and CTO and COO, and it was such a good interview, we decided to bring it out and let you all take a look at it instead of just transcribing it to text as we would have done. And so let's chat with Dan about wide bandgap semiconductors and what Navitas is doing with on-chip drivers. Navitas is one of the companies that's working at the front edge of this technology, and they're actually doing some interesting things with driver electronics on die with the semiconductors. So let's bring Dan on board and say hello. Hi, Dan. How are you doing today?
Doing well, Alex.
Good to see you here. Good to see you here. You know, when you think about it, power electronics has gone through such an incredible renaissance over the years. You know, once upon a time, you were lucky if they drew on the circuit board where to put the power. And today, they're thinking about power as a primary aspect walking into any design.
Well, power is so critical. It controls so many things and has to deliver exactly the requirements for the particular application. So it just can't be a second thought anymore.
Well, you know, and that's interesting because it's almost as if the wide bandgap revolution, the stage was set with digital power management and the other aspects of power topologies that have really made power a critical issue, especially now on the demand side. You've got vehicles that want to run longer on batteries. You've got Internet of Thing devices that want to run longer on batteries, server farms that want to run more efficiently. I mean, even the energy density of wall warts, it's all touched by this technology, right?
Definitely so. The mobile chargers are the first area to really adopt GaN in high volume. And if you're charging your phone or laptop much faster, 10 times faster than you used to, you can appreciate that you most likely have a Navitas device inside that charger.
Well, you know, that's very interesting in that aspect. What are the things that make Navitas special? I understand you're doing some interesting things with the driver electronics. How does that apply?
Well, we put the drive electronics right on the same chip. And when you put the drive electronics on the same chip, you can switch the chip not only much faster, but with virtually no loss. No energy wasted, nothing turning into heat to overheat your system or make it too hot to touch.
Well, you know, when you hear that, couldn't I do that with silicon? Why do I need wide bandgap for that?
Well, silicon was a great technology, and it had its day, and it is still having its day in most marketplaces today. Wide bandgap technology is coming along and replacing it and picking up steam and likely to replace it in many areas so quickly now. And it's because with wide bandgap, you can withstand higher electric fields. You can do it in smaller devices. You can switch so much faster because the devices have so much less parasitic capacitance. They just outperform silicon in every way.
Now, how would you differentiate gallium nitride from silicon carbide? I understand they're both wide bandgap semiconductors.
Right. So gallium nitride has been a little later to come onto the scene than silicon carbide, which has been around for a decade or so. But gallium nitride, in terms of switching speed, is so much faster than silicon carbide. You can operate your power supplies or other power electronic applications at frequencies that even silicon carbide can't reach.
Interesting. Well, speed gives you a lot of benefits, doesn't it? I mean, there are application spaces like LiDAR that need that kind of speed, right?
Well, LiDAR is an interesting application. It's ranging for cars and detecting objects around cars. It's going to be so important for autonomous driving. But it does require very specialized electronic circuits that can deliver bursts of current in nanoseconds to send that light pulse out and then get the reflection back. So you need a switch that can basically just instantaneously turn on and off. And GaN is really well suited for that. It is, you know, a lower voltage application. So LiDAR systems operate below 100 volts, and many of the systems that need high frequency switching operate from line voltages that come out of the utility, 110, 220 volts, 240 volts, and you need high voltage devices for that, where GaN is really an ideal choice.
Excellent point. Now, aren't there other aspects to the speed? Lets you shrink your transformer size, for example, right?
It lets you shrink a lot of things, the transformer being one of them. Other things like inductors and capacitors, filter components can all shrink. The reason they can shrink is that as you switch faster, you're delivering energy in much smaller chunks. So you have to store less energy in those energy storage elements.
Well, that gives you all kinds of cascading benefits, doesn't it? You know, it applies directly to the whole aspect of computing, because you want it smaller and faster and more efficient, longer battery. That plays all the way into it, doesn't it?
Sure does. Not only does it make your computer systems and your data centers more powerful or smaller, but it also improves energy efficiency, and that's a big thing to us right now. Since Navitas, actually the name itself means energy, we're all about bringing new energy, but also saving energy for the planet.
Well, speaking of Navitas, what made you decide to start the company up? I mean, it's a very novel concept for advanced wide bandgap semiconductor play. What got you out of the box?
It was a long-standing interest in starting with generally what kind of new materials could bring more efficient switches. Having worked in the field of silicon switches for a couple of decades, I just felt that the time had come for new materials, and I worked in silicon carbide, I worked in GaN. Gene Sheridan, our CEO, and I worked together to bring GaN technology into the company we were working for in the early 2000s. And the field was still a bit immature back then, and not ready for the market. So we both went our separate ways and did some other things for a while, but we decided to come back together in 2014, seeing that GaN technology was reaching the stage where it could be reliable and cost effective.
Well, you know, that whole aspect, right? Cost effective, it means that you could do more things for more people at a lower price. You would almost think that it's almost as if it was teed up for computing applications, you know, because of the switching speeds, because of the way it lends itself to digital applications. It's like it found a sweet spot there in computing.
Yes, well, computing is a very demanding application, of course, needs very high precision power, and gallium nitride is ideally suited for bringing power in those precision quantities required by computers. One of the big things with computers is that the load is constantly varying as the computer executes its system protocols. The currents go up and down. There's a lot of transient in the load. And you need a system that can respond extremely fast to those transients in the load. So since gallium nitride can easily switch well up into the megahertz range of switching, it can handle those load transients better than any other semiconductor.
So, so Dan, you know, when you think about that whole aspect, where do you see it going? What do you see as some of the future for GaN?
Well, we've started heavily in the mobile charger space, but we are not just staying with small batteries. We're going to be charging every kind of battery you can imagine, all the way up to electric vehicle size batteries. And certainly we're not going to stop there. We're looking at power supplies for powering servers and game stations and all-in-one computers and high widescreen TVs, flat panel TVs, But then, of course, so many other applications. We see solar energy as a critical climate change, battling element. And so we're looking to make inverters more efficient for solar. And as we continue on, other things such as lighting and motion control and robotics, all of these are fertile fields that GaN can bring great changes to.
I agree with you completely, Dan. It's like I said, I've been in the power space for a really long time, and to see the changes in topologies and materials, abilities and applications, it's fascinating. Do you have any final thoughts for our audience before we let you go?
Well, final thought would be gallium nitride is a technology that is really going to help the industry and be a benefit to all the consumers of electronic applications everywhere. And so we're really excited about it and look forward to expanding our reach and expanding the penetration of GaN and other wide bandgap components.
Excellent. Very cool, Dan.
So that was Dan Kinzer, co-founder, COO, CTO of Navitas, a company doing some very interesting things in the wide bandgap gallium nitride space. Thanks for taking the time for watching. We really appreciate it.